Welcome to the Heidelberg Centre. My name is Natalia and I'll be one of your professors here at the School of Graphic Communications Management. I'm together here with my colleague Ian Bates and we're going to show you around the GCM building. We're so excited to have you arrive for your first year at GCM, and we wanted you to get to see some of the amazing equipment and labs that you'll get to use throughout your career as a student here. So welcome to our little tour and come along. So welcome to one of two Mac labs here in the Heidelberg Centre. This is where it all begins. This is where the magic starts. You'll notice we have a wonderful facility and lots of Macs available for you. All of your design work will be starting here, and a lot of the pre-media or pre-press work will also happen on these computers. So while they look like standard machines, some of the software that's available in our labs in particular is not software that you would have at home. So normally when we print a product like a book or a poster, it starts on the computer where the designer designs it, and then it needs to be processed through a series of workflow stages and workflow equipment that is first and foremost software, and you'll be using that software in this particular lab. You'll be spending quite a bit of time here, hopefully enjoyably, designing and thinking of and ideating all of the work that you're going to be then producing here at GCM, all the way through to the final stages in our downstairs labs. So we were just in our Mac labs where you saw the computers where you'll be designing all of your work. Once you create a design, we have to make sure that it prints correctly before it goes downstairs to the printing press, and we do that through a process called proofing. So on either side of me here, you see two Epson devices, Epson proofers, and essentially these run like the printers that you would be used to at home, except they're much larger and much more capable of doing a variety of things. In particular, one of the things that they do really well is that they control color really well. Color in the printing industry is very important. I'll give you a packaging example. Let's say that you saw two packages on the shelf, two Coca-Cola cans or two boxes of cereal, and one of them was differently colored. Maybe it was a little bit more muted or faded. You would assume that that package has gone off or gone bad. And so it's really important to ensure that the designed color is as intended. And one of the ways that we make sure that this happens is to proof that color or print a proof of that color and make that available to the press operator downstairs, so then he could use industry standard equipment, or she can use standard industry equipment to make sure that the color matches on the final printed product. Welcome to the I/O area, or Input-Output Lab. We have now taken a look at our computers and our proofers. So our designs are ready, they've been proofed, and they're ready to go to the printing press. But before they do that, we need to create plates. So this is a device called the Magnus 400. It's by Kodak, and it is used to make aluminum printing plates, much like this one. You will notice that there's sort of like a green film on the front of the plate, and in certain areas it's been rubbed away, and that was rubbed away for demonstration, usually using some solvent. And so this is what gets imaged inside that machine in order to then be taken downstairs to the printing press, mounted on the press, so that these image areas are picked up by the ink and printed on a final sheet of paper. This is one process that is used to make plates, and these plates are for offset printing. We also have another plate making device for flexographic printing right over here. So this is also a plate maker. It's called the CDI Spark by ESCO, and it is used to make printing plates for a flexo press. The final result of this particular device is a flexible printing plate that is mounted onto a cylinder on our flexo press downstairs. Flexo presses, as you will hear about shortly, are used to make a majority of flexible packaging in our industry. So think chip bags, for example. Before these plates look like this, sort of like a rubber stamp, they look like this. And so what you see here, there's quite a thickness on this plate, is essentially a series of rubber polymers and a black coating to shield different pieces of image and non-image area. And this device is used to expose the image area onto that printing plate. So you'll notice that the black area stays, and that's the mask. And the area that's been exposed or ablated by a laser that's inside this machine is the image area, or where the ink will be picked up in order to print. Now, to get from here all the way to here, we need to process the plates. And I like to call this the spa for flexo. So we go over to this device, and this device is called the Orbital X. And normally what you would see inside here underneath is a nice bubble bath. We would place the sheet on this sticky back area here, like so, and it would go down, oh, it is very sticky, and it would go down into the bubble bath, get washed away, and then processed into a variety of steps here. So there's some UV light in here, some dryers to make sure that the plate is properly exposed and dried and ready for the flexo plate. And so you can open these and make your flexo plates down for the flexo press. As a GCM student, you'll have an opportunity to do all of this in here, to test all of this equipment, perhaps even to do some research on this equipment to figure out, are there better or more efficient ways to make plates, or is there something unique or innovative that we can do with these processes here within our school? So this is a Roland Device. It's one of my favorite pieces of equipment at GCM. It looks like a proofer, but it has an additional functionality which makes it a fan favorite in the packaging industry. So in addition to printing fairly wide sheets of paper, as you would see for signage, this particular piece of equipment is what we call a printer cutter. So in addition to printing things, it is also able to cut them quite uniquely. So it's got a little knife that runs around and can do a very intricate shape. You would see these in decals, like the types of things that you like to put on the back of a laptop, but you can also see them for other production areas like vehicle wraps or other unique signage decals for store windows. Maybe you've seen store hours are printed on little tiny sheets of vinyl. So this machine can do all sorts of variety of outputs that are used in the sign industry as well as in the packaging industry. The other thing that I love about this piece of equipment is it can actually handle a very large variety of substrates. So we can print on all sorts of things. So vinyl like this, sticky back, regular signage sort of paper, but also unique substrates that you'll see behind me here. So if you've ever sat on a bus that's fully printed from the outside, but when you get inside, you can still look out the window. That is a perforated vinyl that we are able to produce on this particular Roland device. So here we have the Kongsberg cutting table. This is a very, very flexible machine used for package prototyping as well as signage. All of the examples you see around me here have been created by the Kongsberg Table, and essentially it's a very large cutting device that uses very intricate knife and camera systems to run around this sort of reverse hockey table where things are suctioned down and run around those items and cut them out. So you'll notice that this is the sort of hub of the table. So we lay substrates out onto here, and then we have different tools available through this particular machine. There's 3 stations, and we can do things like perforate with a perf wheel, cut with a cutting knife, different types of substrates. So for example, you could do paperboard, which is just a single sheet of paper. I'm not strong enough to lift these out. Or corrugated paper that has corrugated ridges sort of at the edge. It can handle a very, very large variety of substrates to create different outputs. I'll show you examples. So signage like this, stand-up signage that you would see in stores, so you could produce on this type of table. Perhaps you've ordered on the internet things that look like gallery frames that you can order off of something like Vistaprint. If you take a look at the back side of this, this was also produced by this table with a very specific V-notch knife that creates this sort of groove so that you can then fold this up very easily and have this gallery style edge. And we also have a whole bunch of packaging samples that you can create on this table. So here's a little paperboard box that can be created on a Kongsberg table. And essentially you would have a large substrate here, and that particular printing head would move around and knife all of the edges of this box, as well as doing the scoring. So you'll notice that this is very easy for me to fold, and that is because a scoring wheel has already come through and made that fold for me so that I can assemble this box before it's finished. We would use this to prototype boxes to make sure that the final version of a box that we are going to take to final production works, but also for short run printing. So for example, if you were doing specialty chocolates like this, perhaps you printed them on a digital proofer and everybody at your work is going to get their unique chocolate box. This one says Natalia, that one says Ian, and so on and so forth. You would use this type of device to cut them out and assemble them together.
Hi everybody, welcome to GCM. My name's Ian Bates. I'm one of the professors here in GCM, and we're going to take a few minutes to look at some of the printing machines in our printing press lab, which is in the basement of the Heidelberg Centre. This printing press behind me is a Heidelberg Printmaster. It's a 4-color offset lithographic printing press that prints on sheets of paper. This particular press prints on large sheets and prints up to 13,000 sheets per hour, up to 4 colors at a time. So here are some examples of work that students have done on this press in the past. This is a color test using some brand colors. This is a wall calendar that students can write their dates and due dates and deadlines on, or put some stickers on. It happens also to be a 2-sided job. And this particular job is a series of book covers. So it would be cut apart and students will be able to put covers to different portfolios or books. So this particular press works by taking sheets in from the in-feed, and then it goes through these 4 identical printing units. Each one looks a little bit like a tower. Each printing unit puts one color on the sheet, one after the other. In 4-color process printing, we use the 4 process colors: cyan, magenta, yellow, and black. And with those 4 colors, we can make up almost every other color that exists. For this particular piece of equipment, the image comes from an aluminum printing plate. So this would be the printing plate for the calendars that I showed you before. And this plate gets mounted onto one of the printing units, it picks up ink, and then transfers it onto the sheet of paper. So as a GCM student, you're going to learn how to make plates in our pre-press area. It all starts from artwork on a computer, and then how to mount plates, how to set up the press, how to evaluate printed sheets for quality. The ink for this type of press, you might be surprised to find, comes in a large can like this, and it's a paste ink. It's a thick paste, kind of the consistency of margarine or shortening, so we use an ink knife, a big spatula, to scoop it out and to put it into the printing units. It's not a pourable liquid. We have 2 other offset lithographic printing presses here at GCM as well that I'm going to show you. We have these smaller presses made by the same company, Heidelberg, but instead of being the large Heidelberg Printmaster, this is a Heidelberg Quickmaster 2-color press. So we can put 2 colors on the sheet in one pass. In first year, students use these smaller presses, the 2-color presses, together with their instructors, teaching assistants, working in small groups. Normally by the time students reach second year, then they're going to have some demonstrations on the larger pieces of equipment. Welcome back. In this lab, we're in our packaging lab. So in our packaging lab, we have a flexographic printing press. Flexo printing, or the flexographic printing process, is used for a lot of packaging applications. Labels, cartons, boxes, pouches, potato chip bags, even things like a coffee cup or a takeout bag from a fast food place. So here are some of the products that students have printed on our flexographic press. One of them are these "Hello, my name is" name tags. So it's printed on an adhesive label stock. We can also print on a metallized foil stock. Students have done a little bit of brand redesign for different food brands, food packaging labels, and this particular group of students did a job of redesigning a Band-Aid package, so a small carton. Now, how does flexographic printing work? Flexographic printing is usually printed from rolls of paper, so that's why you can see the products we're looking at are in rolls. So we start with the far end of the press, feeding a roll of paper in, and then it goes through each of the 7 different print stations that are behind. And each print station can put down one color of ink onto the paper. At the end, we have the ability to die cut, which means to cut shapes, which could be a rectangular label, it could be circles, it could be a star, it could be any type of a shape. Think about a label that goes on a Windex bottle, or a bottle of dish detergent at home, or a bottle of shampoo. That would be printed on a press like the one you see behind me. So this press can print 7 colors. Each color has its own printing plate. And in flexography, the printing plates are flexible, made out of a rubber or photopolymer material with a raised surface. So actually, it's a little bit like a rubber stamp. We mount the printing plate onto a plate cylinder. This is just an aluminum cylinder. We would use double-sided tape to do that. And when we mount the plate onto the cylinder, it's going to look like this. Here's a cylinder with the plate already mounted using the double-sided tape. So each plate, representing one color of the job, goes into one printing unit. We add the ink, and then the press will print that color one after the other as the job goes through the press. Now, because this is our packaging lab, we have printing associated with product packaging, but we also do have some packaging equipment. Packaging is an important area for our industry. One piece of packaging equipment that I'd like to show you, we added a couple of years ago at GCM. This is a PFM Hawk. And the purpose of this machine is to wrap and seal around a small product. So for example, think about a granola bar, a chocolate bar, a pack of collector cards or hockey cards. Those would be packaged on a machine similar to this. So how does it work? The product enters from the left. We have a plastic film, which in this case is clear, but it could be pre-printed, for example, with a granola bar graphics. It goes and it gets wrapped around the product. We have the ability to put an adhesive label onto it as well, which you can see up at the top of the machine. And then as the process moves forward, what happens is that the machine will heat seal the plastic together around a given product, and it comes out a conveyor belt on the right-hand side. So this is a small machine. There are larger ones like this in industry, but everything that you see here at GCM are standard pieces of industry equipment. These are not small educational devices or models. These are the same kinds of equipment that's used in the printing and packaging industry.
Welcome to our digital output press lab. Here I'm standing in front of our Ricoh Pro C7210X laser printer. Now, it's a little bit beefier than your regular office printer. We have our printing unit here, but what's special about our unit here is we have a high capacity feed tray, so that lets us put in a couple thousand sheets of paper so that the machine can go up to production and stay efficient. We also have a special finishing unit here. So we have a unit that does 2 really important things. One is it can do specialty folds, so it can do a trifold brochure, so that's like a 3-panel brochure. It can also make us brochures that are stapled in the middle or stapled on the corners. So that's kind of a great tool to have if you're a designer creating booklets, brochures, pamphlets, or promotional materials. Now, this is a 4-color press, which is not so special, right? So we have our cyan, magenta, yellow, and black, but what's actually really special about this digital press is that we can add a 5th color. So right now we have a special color clear that's installed in this printer, but we can add in, so we have clear, we have neon yellow, neon pink, white, and invisible red. Now I'll show you what that looks like and why that's kind of important. So if you're printing tickets and you want to make sure no one's counterfeiting your products, maybe you want to print with invisible red and then use something like a blue light detector to actually shine a light on your printed material. So I have an example here of something we printed that has CMYK, so this has got the black in it. We have neon yellow right here, and then we also have clear, plus we have invisible red. So I'll show you. The neon yellow is going to get picked up really easily, so you see the neon yellow. Clear is kind of hard to see, but there, I don't know if you can pick that up, but you see the invisible red. So that's a kind of interesting security feature that we can print with. So if you're a designer, you can think about how you can make sure your product is doesn't get counterfeit. So you can build that in. So if you're building a product label for, say, prescription drugs, you can put in some sort of anti-counterfeit protective screening into it as well. Over here we have an example of cyan, magenta, yellow, black plus neon yellow, and as soon as I shine the light on it, you should be able to pick up all the details that one of our students actually designed as a poster. So kind of a neat feature. Think about your creativity, think about how you can build some wow and pizzazz into some of your marketing material if you're a designer working with something that's not just cyan, magenta, yellow, black.
Hi everybody, welcome to the Bindery, or the Bindery Lab here at GCM. This piece of equipment that I was just using is called a polar cutter, or a polar guillotine cutter, and what it does is, as you saw in the quick demonstration, is it can cut through a large stack of paper quickly. It's programmable so that we can program in the different dimensions for cutting. We can cut a large sheet down into smaller ones. In the Bindery as a whole, what we have is we have equipment that's used for cutting, folding, making of books or booklets, or turning the big large sheets from a printing press into a finished product that somebody can use. Rarely is a sheet from the printing press ready to be used by the end user. We usually need to trim it, maybe we need to fold it, we need to maybe drill holes or punch holes, staple it, stitch it, turn it into a book, do various things like that. And that all happens here in the Bindery, which is also known as our Bindery and finishing or post-press area. In addition to the polar cutter, which I just showed you, beside me, we have a folding machine. This is called a Stahl folder, made by the company Stahl. This folder has a right angle attachment to it so that we can make folds in both directions across a sheet of paper. One of the most common uses for a folding machine like this is to take a large sheet that comes off our printing press and to fold it into what we call a signature. And a signature represents how a book is built. So all of the signatures will get gathered together and attached with either glue or thread or other tools into a book. Once that happens, we can trim the edges so that we've got nice clean edges at the head, the foot, and the foredge, and then we have a book. So here's an example of a Stahl folder. You'll certainly see equipment like this in industry, and you'll have the opportunity to use some of this equipment in first year and second year at GCM. In this section of the binding and finishing lab, or post-press lab, we have equipment that turns signatures. Remember that a signature is a folded sheet of paper, printed on a printing press, folded on a folding machine. These pieces of equipment turn a signature into a finished booklet or book. So this particular piece of equipment behind me is a Muller Martini Valore saddle stitcher. Saddle stitcher because what happens is the individual signatures are fed at the right hand end of the machine onto a belt or saddle. And that saddle moves from right to left. All of the signatures get dropped onto it. And then here, inside this covered area, staples go through the spine. So any magazine or booklet that you've seen that has staples that go through the spine would be made on a machine like this. A couple of interesting features. Staples, of course, at home, staples that you buy are preformed, and they usually come in a stick or of preformed staples. On this particular machine, the staples are actually formed by the machine. So we have some staple wire that comes on a spool. You can see some spools of wire behind the machine. They're formed into staples inside here so that the exact shape and size of the staple can be adjusted to the demands of the job. In this area, the final booklet is trimmed and delivered products down here at the end would be ready to go to the client. In this part of the bindery, what we have is another type of bookmaking machine. This is a Muller-Martini Amigo Plus Perfect Binder. Perfect binding means for a glue-bound, soft-covered book. So if you think about paperback books, a paperback book that you pick up from the library or that you buy at a bookstore would be made on a machine like this. So the signatures, of course, are printed and folded, as we've seen before. A number of signatures would be gathered together. They would be inserted by hand by an operator into this clamp. And as the machine runs, the inside part of the machine turns counterclockwise like a carousel. In the second stage, the machine prepares the spine of the book to receive glue. It does that by roughing up the spine of the book using some blades. And then the back of the book is glued using a hot melt adhesive glue. After that, the book covers, which have been pre-printed and trimmed, get inserted onto the book and they stick to the hot glue. And then lastly, the book is delivered. When the book is delivered, it's going to look like this, and it needs to be trimmed afterwards on a guillotine to trim the head, the foot, and the foredge of the book so that we have nice even edges and can open all of the pages. With a machine like this, our students in the past have made projects like this grad book. This is a book of all of our graduating students, which they tend to do every year, and it tells some information about them, their career goals, their studies, their minors, their concentrations, maybe where they did their internship, and then at GCM we distribute these grad books to employers and potential employers. In addition to making it as a physical book, they also tend to make it most years also as an e-book, which can be read electronically online. Here's a grad book from a different year from some of our students, and that also was made on a machine just like this. Some other equipment that I'd like to show you here in the bindery are some pieces of small hand-operated equipment that you will be using in your first year labs at GCM. This first one is a hot foil machine. So we have the ability to put small metal letters into here. It gets heated up with an electric element. It becomes hot to the touch. And then we use these rolls of fancy foil. They can have a holographic pattern, or you can choose different colors, whether it be red, black, green, silver, white. And with this machine, you can stamp a foil image onto any type of a product. So common examples would be a book cover that has an embossed foil image. But you could also do something like a pencil on a machine like this. We have cutting machines to make rounded corners, for example, on a business card or a greeting card or maybe a book cover. We have these machines over here, which you may have seen somewhere in the past, that are used to make Surlocks binding or different types of wire or plastic coil binding. So this is what we call a mechanical binding method because we're using mechanical means to hold all of the pages together. So with a machine like this, the Duomac, we can punch the holes or slots and also put on the comb or the coil necessary to bind all of the sheets together. One of the most simple binding methods, very good for books that have to sit flat. So think, for example, about a music book that somebody uses at a piano, maybe a cookbook. You want the book to sit flat while it's being used. You don't want to have to hold it flat. This is a great binding method for that. The next piece of equipment here is a hand die cutter. What's a die? Well, a die is a sharp cutting tool. This one you may be able to see is in the shape of 6 stars. So there are some cutting edges on there that are sharp. It actually works a lot like a cookie cutter. And the way that you would use this is by placing the die and a sheet of paper in there and using pressure to cut through it, just like a cookie cutter. This could be used to cut greeting cards, business cards, shelf hangers, pieces of packaging, anything that has an unusual or intricate shape to it. The last couple of pieces of equipment that I'll show you here, this is a paper drill. This is made by a company called Challenge, which is well known in the binding and finishing industry. This is a small paper drill. It has only one drill bit. There are others that have more. And this is used to drill holes in paper. So we would put a large stack, 500 or 1,000 sheets of paper, turn on the drill, and then we can drill holes through it. So this would be, for example, to make paper that would go into a 3-ring binder or other types of mechanical binding methods. Or let's say you're to make something like a calendar or a poster that you want to be able to hang on a hook on the wall. You might drill a single hole at the top of the product for that purpose.